Given f of x is equal to 2 to the x over the interval from -2 to 3, determine whether each type of approximation is an underestimate or an overestimate, and why. So notice that the width or number of rectangles / trapezoids is irrelevant. So when you're doing these types of problems where you have to figure out if it's an underestimate or an overestimate, I recommend making it really obvious by just setting up with 1 or 2 shapes. Okay, so if I'm going from -2 to 3, and I'm trying to figure out if a left endpoint rectangle will be an under or an overestimate, I'm just going to set this up with, let's say, 2 rectangles. Okay, and I'm going to start my first rectangle on the left-hand side like you're supposed to. I've got my first rectangle here, and I'm going to make it like, I'll do like, I don't know, halfway-ish. And then my next rectangle will be here. Okay, well, you can clearly see that that is an underestimate. And why? So what is it about the function that makes a left endpoint rectangle an underestimate versus an overestimate? So for example, if my function looked like this, left endpoint rectangles would be an overestimate. So what is it about 2 to the x specifically that makes it an underestimate, not an overestimate? It's because f of x is increasing. Okay, f of x is increasing. If f of x was decreasing, as you can see, left endpoint rectangles would be overestimates. But because they are underneath the function, we've got like this missing area here and here, then my rectangles are an underestimate. So let's do the same thing with right endpoint rectangles. So now I'm going to start on the right-hand side. I'm going to go up. I'm going to create a rectangle. And then I'm just going to do like one more rectangle. You could just, I'm using 2 rectangles. You could even just do 1. And you can see that's like a way overestimate. I'm like adding all of this area here when the area under the curve is actually only this area. So this is clearly an overestimate. Again, that's why I say just set it up with like 1 or 2 so that it's really clear for you whether it's going to be an underestimate or an overestimate. And it's an overestimate because, and then what is it about the function that's overestimate? Whereas if it looked like this, right endpoint rectangle would be an underestimate. That's because f of x is increasing. So again, because f of x has a positive slope, that means a right endpoint rectangle is going to end up above it, whereas a left endpoint rectangle would end up far below it. So I say far, it might be close, but in this position, in this situation, it's clearly like way an underestimate. So just draw a quick sketch. Like you just need to know if your function is increasing or decreasing to tell you whether your rectangles are going to be overestimates or underestimates. Okay. So midpoint rectangles and trapezoids, similar but slightly different here. So with a midpoint rectangle, let's figure this out. All right, so I'm going to go about halfway to find my midpoint rectangle. So that's going to be right about here. Now it's kind of hard to see, so it's not, but again, that's why we want it to like be really obvious with just one rectangle. So we've got this area that's like above it, but then we've got this area that's below the curve, but above the rectangle. So if I was to calculate the area between the curve and the x-axis, I would say that that area is larger than the area of the rectangle because the rectangle is doing a small overestimate here, but it's doing a large underestimate here. So the midpoint is an underestimate. And midpoint rectangles are typically harder to kind of see what's going on. And the reason is not because f of x is increasing. If you were to look at a decreasing function like this, okay, your midpoint rectangle might still be an underestimate. So the reason is not because the function is increasing. It's actually because of the concavity. Okay, if I have a concave up function, a midpoint rectangle, I'll make it really obvious. I'll do like a whole concave up function. a midpoint rectangle is an underestimate. So it's an underestimate because f of x is concave up. And the way that you can tell it's concave up, like think about the shape of the curve. Like, does it look like part of an upwards parabola or does it look like part of a downwards parabola? If it looks like part of an upwards parabola, then it's concave up. If it looks like it's part of a downwards parabola, it's concave down. So this function is concave up, and a midpoint rectangle is an underestimate. Okay. And then let's try a trapezoid. Trapezoid is a lot easier to figure out here. All right, trapezoid, clearly an overestimate because f of x is, all right, let's figure out if this has to do with increasing, decreasing, or concavity. So let's draw a decreasing function. Okay, this trapezoid is also an overestimate. So it's not because the function is increasing or decreasing. The trapezoid is an overestimate in both of the examples I gave. But what do both of these examples have in common? They are both concave up. If your function is concave up, a trapezoid is going to be an overestimate. But if your function is concave down, your trapezoid will be an underestimate. So again, because f of x is concave up, trapezoids are an overestimate. Okay. Now, I did not tell you the number of trapezoids. Sometimes they will give you the number of trapezoids and you have to figure it out. So let's say I said, okay, there are 5 trapezoids. And it's like, it's really hard to see if the trapezoids are above or below. So if they even do that, where they give you smaller trapezoids or smaller midpoint rectangles or whatever, all I want you to know is it's because of increasing or decreasing for rectangles that are left or right endpoints. And for midpoint and trapezoids, it's because of concavity. If you can remember that and then just do a quick sketch. Okay, left and right endpoints are because the function is increasing or decreasing. I did that backwards. But so left endpoint, if the function is decreasing, over. Left endpoint, if it's increasing, under. Decreasing, increasing. Right endpoint, under. Right endpoint, over. Okay? And then for concavity, concave up. Midpoint rectangles, under. Trapezoids, over. Concave down. Midpoint rectangles, over. Trapezoids, under. So just do a quick sketch of just like one midpoint rectangle or one trapezoid or one right rectangle or whatever. And then just make a really obvious, like, okay, the function is increasing or decreasing or concave up or concave down so you can figure it out.